It's great to be here today. Look, I thought what I'd do is just give a little bit of an overview of what we currently think we know about the magmatic history of the Narryer Terrane. There are lots of people involved in this research, but I think, and the names are listed there, but I think certainly none of this work would have been possible without the scientific and logistical support of GSWA, so it's very much a collaborative venture. Okay, so the Narryer Terrane is this enigmatic little piece of crust that appears to be welded to the northwest margin of the Yilgarn Craton there. Quite a few questions about this terrain, and many of those questions still remain, and been known for quite a long time from the neodymium data that those rocks have older crustal residence ages. So the question is where those ancient components come from, whether these are truly exotic components or whether there's some nucleus there upon which the rest of the craton has been assembled. So that's a question. How do we relate the Narryer Terrane geology with the geology of the other terrains in a Yilgarn Craton? Are there elements of the geology that can be correlated? What sort of correlations can be made? And lastly, really, in an amazingly metallurgically endowed tract of crust like the Yilgarn Craton, there doesn't appear to be much in the way of mineralisation as yet reported from the Narryer Terrane. So why is that, and actually what is the true mineralisation potential of that terrain? And I would suggest that actually most of those questions could be answered by a much better understanding of the geochronology and the geochemical makeup of the Narryer Terrane, which is something that GSWA are working towards in collaboration with a number of us. I thought I would just go through an events timeline really to start with. So I think things all kicked off in the Narryer Terrane with a very classic study in 1981 by John DeLater and colleagues. And they sampled a bunch of quartz-feldspathic gneisses and did some whole rock rubidium strontium dating and come up with an isochron age there of around about 3350 million years. So that was the first indication of the great antiquity of the gneisses in that part of the Yilgarn Craton. Subsequently, some of those same rocks have been analysed for their zircons, and it turns out that Eoarchean zircons have also been found in some of those samples. So that's really what kicked things off. Shortly after that, there was a discovery of the Hadean detrital zircons, firstly at Mount Narryer as reported in 1983, and then at 1986 as reported in the Jack Hills, a very famous set of papers in high-profile journals. That really stimulated a pulse of activity in the Narryer Terrane. There's a number of people involved there from Curtin University and the ANU, and that work that was done in the late 80s all the way through into the 1990s really did provide the first order chronological framework of the Narryer Terrane. So the ages of the different gneiss packages, the ages of the different granites, perhaps even the timing of metamorphism in the area. So they were some of the seminal studies. And the geology, as it's currently depicted, sometimes looks a little bit like this. So there are supercrustal slivers in there, so the Mount Narryer and Jack Hill supercrustal belts that are shown in grey are dominated by sedimentary rocks. Then you have a series of fault or shear zone bound lozenges that define different gneiss packages with different protolith ages, and all of that is swimming in a sea of Neo-Archean granite. Interestingly, the structural boundaries to the Narryer Terrane with the you and me terrain defined by the Valbalinga fault and the Yalgar fault, I suspect that this will be another instance as more work accumulates that these boundaries will in fact shift. So that's the way the geology is quite often depicted in this area at present. So a quick look at those old components. So the Manfred complex, the oldest rocks in Australia, thought to have derived from a layered mafic intrusion that has been dismembered magmatically and tectonically, all the way down to scale of individual crystals. So these are individual plagioclase megacrysts there strewn throughout a younger gneiss. Zircons are quite complicated in terms of their age distribution, but returned a result that's consistent with igneous crystallisation at about 3730 MA. So the oldest rock in Australia by some margin. The Meabury gneisses are a suite of banded quartz-feldspathic gneisses in the Narryer Terrane. They're very complicated. You can see them from the outcrop photo. There are lots of different components in those rocks. It's no great surprise that the zircon age distributions are also very complicated. But again, they have these very ancient components. So there's evidence for 3730 million year old components in there. There's evidence for 3600 components in there. So that suite of gneisses in the Narryer Terrane is thought to be derived from granitic protoliths of a variety of ages, but including Eoarchean rocks. Then we have the Urata gneisses, which is something that Raf touched on. So these are tonalitic in composition. Again, they're rather complicated in terms of their field occurrence and also in their zircon systematics. crystallization ages inferred for tonellitic protoliths between 3490 and 3440 MA. I picked out one published example there that actually shows a younger zircon age population at around about 3050 MA, which I think is actually quite significant. And then the last major package of paleoarchaea gneisses are the Dougal gneisses, which are derived from quite felsic leucogranitic protoliths, but they are also quite variable at outcrop scale. Crystallization ages of protoliths around about 3370 or so. So they're really the main gneissic packages that have been identified to date. What happened after that? Well, quite a bit actually. So 3300 to 3280, there was the emplacement across the terrain of a suite of porphyritic granodiorites. They're now mainly gneisses. There appears to be a little bit of a gap, although that gap, based on what Raf presented this morning, has already started to contract a little bit. We had the emplacement of some granodioritic rocks at about 3 GA, which have been converted to gneisses that are referred to as the Milga gneisses. There appears to have been another little hiatus in the activity in the Narryer Terrane, and then you had the onset of the widespread granitic magmatism, which kicked in from around about 2750 MA, continued all the way down through to about 2620 MA. That was coincident with high-grade metamorphism, deformation, and that was thought to be the time in the Neo-Archean where the main structural deformational imprint of the belt was established. Not to be neglected are a whole suite of Proterozoic dikes and gabbros that also provide a treasure trove of information, as I think Chris will talk about a little bit more. So what have we been up to at UWA? So for the last 10 years or 12 years or so, we've been undergoing various research programs in the terrain, and really the objective has been to try to shed some light on the very early history of the terrain, so looking at the oldest components. So the main tool that we've used to do that, zircon uranium lead dating, but also some whole rock garnet lutetium hafnium dating and some dating of rare earth rich accessory phases. Done a little bit of metamorphic work and a little bit of PT modelling, which has just recently been published in a paper by Naomi Tucker. She has a poster hanging up in the corner of the room. And we had a couple of PhDs as well. Matthew Rowe worked on the granites, and Matilda Boyce is undertaking a study on some of the mafic to ultramafic rocks. So what I thought I'd do is, rather than go through everything there, just to pick out a couple of highlights in some of the work that we've done from a geochronological point of view. First thing we did was to go back and have a look at these old rocks in the Manfred complex, these old gabbros. There was some debate about whether the zircon cargoes in those rocks actually were genuinely intrinsically related to the crystallisation of the gabbros. So we spent a lot of time digging around in the dust there and finding some quite well-preserved gabbroic outcrops, dating the zircons in those, and they've returned very simple age distributions that I think really does reinforce the original assignment of those rocks as around about 30 million year old gabbros. Now, that was a fairly clear-cut result. Some of the host rocks to the gabbros are actually been strongly metamorphosed and show evidence for partial melting. So that photo down there is the host gneisses to the Manfred complex. They're transected by these diffuse networks of leucosome that have relic orthopyroxenes in those. We extracted the zircons from those and found actually the rims of the zircons, low uranium rims, have a fairly strong peak of ages there at around about 3,300 million years. So we'd interpret that as evidence for a granular fuzzy partial melting event at about 3,300, which was something that was actually recognised in the early work in the zircon age populations in the gneisses, but that's a lithological manifestation of that. That's a very high-grade metamorphic event. We actually found quite a bit more of these old gabbros that have been realised. So there's two examples there. Those Luca gabbros are a little bit more deformed, but they're a long way from the type area around Mount Narryer, and they're returning zircon age populations that are also consistent with magmatic crystallisation at around about 3,700. So that complex there, if that was a layered mafic intrusion, then the components have been transposed over quite a large distance across the central part of the Narryer Terrane. We also found a number of these rocks that are quite a bit younger. So they've all been correlated with the Manfred complex, but there are leucogabbros that have zircons that appear to have indicate crystallisation about 3470 MA, so broadly coincident with the Errata gneisses. There are another suite of leucogabbros that have crystallisation ages that are around about 3,400 million years, coincident with the Dougal gneisses. So that style of magmatism that produces those mafic rocks appears to have repeated itself through the magmatic history of at least the early part of the Narryer Terrane. So that was an unexpected finding in some ways. The Meabury gneisses, so we returned and had a look at some of those, and the complicated rocks, as you would expect, produce complicated answers. So, but again, reaffirming this idea that there are Eoarchean components in those rocks, 3700 all the way down to 3600 MA, so very old igneous protoliths that have been reworked. But we also found some of these rocks that have much more simpler zircon age distributions, like the one on the bottom there with a single zircon age population of about 3620 MA. So those sort of rocks are more useful to us from a petrological point of view because we can understand that that's a single phase of magmatism. We can understand the composition of that and try to relate that back into some sort of process. So there are those ones. That picture explains quite a lot actually, but the main point that I wanted to make was that a lot of the banded gneisses that we come across in the central part of the Narryer Terrane, they look a little bit like that, so they are complicated rocks with different components within them, but quite a lot of them actually don't have the very old zircon packages. So that one there, the main zircon age populations are around about 3470 MA, so it's correlated with the Meabury gneiss, but it really does lack substantive evidence for those older protoliths. So that's a pattern that was repeated in a lot of places across the Narryer Terrane. So if you go back and have a look at the very old or 1997 edition of the Biro geological sheet, and that shows the central part of the Narryer Terrane. And what I've done there is just put a red circle around all the areas where the Meabury gneiss has been mapped. So that was a map that was put together by John Myers and colleagues. And we visited all of those sites and had a look at all of those rocks in those areas, and it turns out the ones that contain the 3600 million year old zircons are actually spatially a bit more restricted. So what that suggests is that those old components are certainly present, but the Eoarchean components appear to be a little bit more restricted geographically than what was originally envisaged, at least so far as what we've been able to ascertain. Matthew Rowe did a heroic attempt to sample granites across the Narryer Terrane. Part of his PhD, what he tried to do is to look at different granitic intrusions that are coming up through the different gneiss packages. And the idea there was to see whether there's any correlation between the chemistry of the granites and the age of the gneisses that they intrude. So he collected 43 different granites. 2 of those turned out to be Paleoarchean. Tried to straddle samples across the Narryer Terrane, you and me terrane boundary to see whether there's any isotopic breaks there. So what Matthew came up with, and I won't talk about it in detail, but he recognised that there are a fairly early set of hornblende-bearing tonalites to granodiorites, around about 2740 MA, very widespread suite of granitic rocks, ages of about 2690 MA. That's him on the outcrop looking a bit disconsolate that he can't actually take the whole thing home with him. And then the very last phase of magmatism is a return to some of these more mafic compositions. There's a bit of hornblende in these rocks. They have mafic enclaves, but there are also some more leucocratic rocks as well. So quite a diversity actually in those Neo-Archean granitic rocks. And then once he compiled his age data and plotted them up, they appear to fall into 3 main pulses there. So what he's referred to as stage 1 magmatism, which is around about 2740 MA. Now, he attributed that to a convergent history of the Narryer Terrane and the assembly of the Narryer and the you and me terrane. Then you had stage 2, which is 2690, stage 3 about 2630, which he attributed to intraplate thermal events. A lot of those rocks have A-type granite characteristics, not all of them, but in his model, he thought stage 2 was related to some relaxational post-decompressional melting, possibly augmented by a bit of radiogenic heating. Stage 3 is an interesting one because we start to see some mafic compositions coming back in there as well, so it may well be that there's a mantle input as well that's partly driving that very youngest phase of magmatism. How does all that relate to the regional metamorphisms? An interesting story. So most of the gneisses in the Narryer Terrane are quartz-feldspathic compositions that are not easily amenable to metamorphic modelling, at least not by someone like me, but there are rocks that have much more distinctive assemblages. They tend to be present as little slivers of supracrustal rock. That's one there to garnet, sillimanite, cordierite gneiss. We see rocks that are rich in cordierite and orthopyroxene. There's some little dribbles of partial melting going on there. Those rocks are actually similar to some of the rocks in the supracrustal belt. The Mount Narryer supracrustal belt, cordierite rich units that also show evidence of partial melting. So we wanted to see temporally how they related to the granites, and this was the basis of the study that was just published by Naomi Tucker and others. And what Naomi did was to compare the ages of metamorphism as inferred from the zircons in the metamorphic rocks to the distribution of granite ages. And what she found and what's plotted there shows that there's a reasonably good correspondence between those pulses of granitic magmatism and the ages of different metamorphic rocks. So we see evidence for metamorphism 2740, there's evidence again at 2680, there's evidence again quite young at 2630. Each of those are derived from zircon, and zircon is a good place to start looking at these rocks, but it may not necessarily be the best place to end. So that sort of work is ongoing, looking at dating some other phases as well to try to shore that up a little bit. I just wanted to touch on some evidence that there is even older metamorphism. So I'd mentioned that there was evidence for partial melting of some of the gneisses at 3300 MA. A little more cryptic evidence in some of these other metamorphic rocks. So there's an example there, which is a cordierite orthopyroxene-rich gneissic rock. Zircon age distribution is interesting because there's a main cluster of data there at around about 2980 MA, which is an unusual age in the context of the Narryer. We have quite a few samples that show that actually. And then there's a smearing of data all the way down to about 2800 MA. Again, these are from zircons in these rocks. Zircons are brown coloured, they have very weak structures, they show classic features what people interpret as metamorphic zircons. They're multifaceted, soccer ball looking little grains. So evidence for some sort of event there at 2980, that could be metamorphism, that could be the crystallization age of whatever the protolith to that unusual rock was. Interestingly, when we then looked at the other accessory minerals in the rock, so the thin section there, we can date the monazites and xenotime in situ. The uranium-lead dating of those phases is underway, but the first pass neodymium isotope work established an isochron for those minerals that returned a date of around about 2800 MA. So rather interesting result. Now, lots of ways that you can look at that. So whether that represents some thermal event, whether that's a time of cooling through some closure is something to be further evaluated really. But it is an interesting result, and it's interesting that that 2800 result more or less corresponds to the final cluster of zircon data from that cordierite orthopyroxene gneiss. So we would at this stage prefer to indicate that that's some suggestion of a 2800 thermal event of some kind. That's not the only one. So there are some rocks in the areas that are garnet-rich samples. That particular sample there, we couldn't recover any zircon, so we went ahead and tried to date the garnets by a solution technique. Again, there's a very nice isochron defined by the garnets and the whole rocks that returned an age of around about 2940, which is again a fairly unusual age in the context of the Narryer. It's older than what we would infer to be the main regional granulite facies event, but it's not a million miles away from the age of the zircon populations in some of those other metamorphic rocks. So I think that's sort of tantalising evidence that there are thermal events preserved, at least locally, in some of these rocks in the Narryer terrane. And those sort of ages may well be useful for correlating with other elements across the Yilgarn craton. That brings me to just the last thing I wanted to mention from a geochronological point of view. The Biro South intrusion is a little gabbroic complex in the northwestern part of the Narryer terrane. So we had a look at some of those rocks as well, because dating the mafic rocks, as you all probably know, is quite a difficult undertaking. These rocks are very well preserved, so they have pristine cumulate textures. There's some olivine present there. You can see the well-formed orthopyroxenes. We had access to some drill core through that. We looked at the composition of the chromites, so the chrome spinels, and shown there as the yellow symbols, they're actually quite different from the chromites we find in the older Manfred complex rocks. So that suggests that maybe we're looking at a different petrogenetic system there. So we attempted to date those rocks, and we were fortunate to find some little leucocratic segregations within the gabbroic rocks. Zircon distribution there is rather complicated, but nonetheless there's a very significant peak there at about 30 MA. Now, it's a question of how you want to interpret that. Is it possible that they're cargoes of xenocrystic zircons? The morphology and the zoning characteristics of the zircons, to me, don't really look like that. They do look like cabroic zircons. That age, again, it's coincident with slightly older than that high-grade metamorphism that we think we find evidence for. It's suggesting that there are a phase of mafic magmas that are coming in very early on in the Neo-Archean that really haven't been a little bit under the radar until the present day. So we have more work going on there. We've recovered more zircons from some of the gabbros, so that's something that's in progress. All right, so just a few points to end on then. I think what we've done thus far is really just reinforce some of these major different packages of NASAs, probably shown that 3300 MA event across the Narryer Terrane is a bit more widespread. There seems to be a very close temporal relationship between the metamorphism and the granitic magmatism, which is perhaps not unexpected, but it does raise the question, the relationship between those. Are they, is that a cause and effect type thing, or are they both manifestations of some larger scale lithospheric process, which is probably what we think. And then this evidence for some thermal event a little bit older than what we were expecting at around about 2900, possibly 2800, followed by a gap before you had the onset of the granitic magmatism. So what was that mafic magmatic event? How widely distributed are those gabbros? The one that we dated is associated with some chromites. There's some nickel PG mineralisation associated with those rocks a little bit further north. Are they the same age? These are all things that we don't really yet know. What's the significance of that little magmatic gap as well? So hopefully these questions are on the way to being answered, or at least further constrained. And I think the last point I'd say is that large amounts of the Narryer Terrane still remain underexplored, except perhaps by the local goannas. Certainly to the northwest and to the northeast and to the southwest, there's lots and lots of work to be done there to try to understand the geology better and the geochronological framework. So in that spirit, looking forward to the next field season to go out and have a look at some more rocks. So anyway, that's